Hey guys, how you doing? So for this lesson, we're going to start the next section, which is called integration by use substitution. Now this is actually I really enjoy this topic. It's you get into you're doing integration with a lot more like advanced functions, but it's I don't know. For me, it's kind of fun to do. So up until this point, right, if I asked you guys to do the integral of something that looked like that, okay, the only way that you know how to do that is if you do 3x minus 5 and then you multiply that out 4 times, right? And then you would do the antiderivative from there, right? Which could get very tedious, right? I mean, that's a lot of multiplying. So obviously we want to figure out what's another way we can speed this up a little bit, right? So we have this technique called use substitution. And what you're going to be doing when you're looking for your U term, all right, okay, U is going to be the most inside function that you have, all right, built inside of your entire function. It's the most inside one, okay? So right now, if I'm looking at my my problem, right, I have 3x minus 5, and that's inside of like x to the 4th, right, because the exponent's on the outside like that. Okay, so what I'm going to do is I'm going to call u the most inside function, which is 3x minus 5. So u is 3x minus 5, okay? Now, when you're doing use substitution, it's like kind of the reverse of chain rule, right? So chain rule, you took the derivative of the outside part and then multiplied it by the inside part, okay? Well, now when you're doing use substitution, you're working backwards from that, okay? You have the inside part, the derivative of the inside part somewhere, and then you're going to need to figure out where that came from, all right? So what you need to do after you find what the u term happens to be, okay, is you're going to take the derivative of both sides, all right? So the derivative of u is going to be du over dx, okay? So that's just saying the derivative of u with respect to x, okay? And then that's going to be equal to the derivative of 3x minus 5 is just 3, okay? Now what you guys want to do is you want to multiply the dx term to the other side. So you have du equals 3 dx. Okay. Now what you want to do once you get here is you want to look at your original problem and see, does it match up with what you have, okay? So I see that I have a dx term and I have dx here, okay, but I don't have 3. Right? Obviously, there's no 3 on the outside, like over here, right? So what I need to do is I need to correct this, all right? So we need to fix this line so that it matches the original problem. Okay, so what you're going to do, so the original problem only has dx. It doesn't have the 3, right? So what we're going to do is we're going to divide the 3 to the other side so that it's the same. So you have 1/3 du equals dx, okay? So now that matches up with what you have right here, okay? Once you figured that out, okay, now you're going to rewrite the problem, okay? And what you're going to do is you're going to rewrite it in terms of u instead of in terms of x, okay? So instead of 3x minus 5 to the 4th, I'm going to instead, we already know that 3x minus 5 is equaling to u, okay? So I can rewrite this as u to the 4th, okay? And then dx, right, I'm going to replace with 1/3 du. Okay, so 1/3 du. All right, so this is going to your u term replaces what you have on the inside, and then your dx term, okay, gets replaced with the du term. Okay, now in order to figure out the antiderivative of this, this variable and this need to be the same. Okay, I can't have a u term and a dx term. It doesn't work out that way. It has to be the same variable. Okay, so what you guys are going to do now is this is a constant, this 1/3 here. So what you're allowed to do is move that out front of the integral sign. So you have 1/3 integral of u to the 4th du. Okay, so this constant is just going to kind of go along as you work out the problem. All right, and then what you're going to do from here, is you're going to find the antiderivative, right? Finding the antiderivative of u to the 4th, that's pretty easy, right? You just add 1 to your exponent, divide by your new exponent. So you have 1/3 times u to the 5th over 5, and because we're doing an indefinite integral, plus c. Okay. Now what we can do, right? We've figured out the antiderivative. All right. Now all you have to do is plug your u term back in. All right. So if you again go back up to what you said u was 3x minus 5. All right. So if I simplify this, I have 3x minus 5 over to the 5th, right? Over. Now, if I multiply my denominators here, that's going to give me 15, and then plus c. All right, so that is your final answer there, okay? So again, the big thing is figuring out what is u, okay, and then working from there, all right? So let's jump to the first one. All right, so it says find the integral of 2x times x squared plus 1 squared. Okay, now look for your most inside term. All right, so because this is built inside of the x squared term, okay, I'm going to say u is x squared plus 1. Okay, now again, if you guys do this correctly, when you do the derivative, right, the derivative of u is du. And then you have the derivative of x squared plus 1, we're going to say is 2x dx. If you do this correctly, du should be somewhere in your original problem, okay? So if you look, du, we know is 2x dx, 2x dx, okay? So when I rewrite my problem, du is going to take the place of 2x dx, okay? So your problem now becomes, instead of x squared plus 1 squared, it's just u squared, okay? And then when you write du, right, that's taking the place of the 2x part and the dx part, okay? So you're keeping everything the same. And then you're just going to find the antiderivative from there, all right? So you got u cubed over 3 plus c, all right? And then you're just going to plug what your u term is back in. So you got x squared plus 1 to the 3rd over 3 plus c. All right, so it's pretty straightforward like that. Okay, so if I'm looking at the second one, right, what would be the most inside term, right? X squared minus 1, that's going to be the most inside term because it's built inside of to the 5th power, right? So u is x squared minus 1. All right, so the derivative of that is going to be 2x dx, okay? Now, if you look at your original problem, you have x dx, okay? So the only thing that's messing that up here is the 2, okay? So what you're going to do to correct it is you're going to divide that 2 over. So you have 1/2 du equals x dx, right? Because you're going to divide everything by 2 now. Okay, so now you have the x dx that you need, right? Now the only thing you have to do when you rewrite it is that you're going to need to rewrite the one with the 1/2 out front. Okay, so you have your integral, you're going to put the 1/2 out front, and then you got u to the 5th du, right? Everything is staying the same. We're just putting it in terms of u now, all right? So you got 1/2 u to the 6th over 6 plus c, all right? So this will become x squared minus 1 to the 6th over 12 plus c. Okay, so again, when you're rewriting it, you're writing it into a much more easier antiderivative. Okay, but even though you're rewriting it, everything has its place, right? Du is taking the place of x dx, right? U to the 5th is taking place of x squared minus 1 to the 5th. So you're keeping everything the same. And then if you have a number out front, like this 1/2 that we had, right? It's allowing you to keep everything the same. So you're rewriting it in a different way, but everything stays the same. Okay. And then I'll do 2 more. So for this first one, right, you got 3x cubed times sine of 2x to the 4th plus 1. So the most inside function should be 2x to the 4th plus 1. Okay, so I'm going to call that my u term. So 2x to the 4th plus 1. Okay, now du is going to be 8x cubed dx. Okay, now looking at what you have in the original problem, right? The original problem, you have 3x cubed dx. Okay, now what could I multiply 8 by so that it becomes 3x cubed instead of 8x cubed? So if I do that kind of off to the side here, right, I need to multiply 8 times something so that I get just like 3 over 1, right? So if I multiply this by 3 over 8, right, these 8 terms are going to cancel each other out, right? And that's going to give me 3 over 1, right? So what I can do is I can put 3 over 8 here, multiply the whole thing by 3 over 8. And what that'll give you is you got 3 over 8 du equals 3x cubed dx. Okay, so when you rewrite your problem now, right, you got your 3x cubed dx from the original, and then you just need to remember to write 3/8 out front. Okay, so let's do that. So we got integral, you got 3/8 out front, and then you got sine of u du. All right, again, when you're writing the du part, that's taking place of 3x cubed and the dx. Okay, so antiderivative of sine becomes negative cosine. So you got negative 3/8 cosine of u plus c, and then you just plug u back in. So negative 3/8 cosine of 2x to the 4th plus 1 plus c. Okay. All right, and then the last one that we'll do, you got x times x squared minus square root of x squared minus 1, x squared minus 2, sorry. So since that's inside the root, we're going to say that that's the u term. And then the derivative of that is 2x dx, right? Now you have x dx, right? So that means we need to divide the the 2 over to the other side. So 1/2. So divide everything by 2. So that's going to give you 1/2 du equals x dx. All right. So you have your 1/2 out front, and then instead of the square root of u, you can do u to the 1/2. Obviously, because we need to find the antiderivative. Okay. So this becomes 1/2 times u to the 3/2 over 3/2 plus c. All right, so then we're just going to simplify this a little bit. So you got 1/2 times 2/3 u to the 3/2 plus c. Now these 2's are going to cancel. So you got 1/3, okay, u to the 3/2 plus c. And then you can just replace the u back in, which we said u was x squared minus 2. So x squared minus 2 to the 3/2. And then you're done. Okay. So for this first part, again, we're just working on figuring out what u is, du, and then substituting back in. So if you guys have any questions, please let me know. Thanks.